This is R.D. Sharma solution, class 12, chapter 7, adjoint and inverse of a matrix. Exercise is 7.1. Now this type of question, there are many questions like this, and the way of doing it is almost similar. So we'll do this question properly because we have already A, and A squared is simply multiplication of A with A. Identity matrix, it is 2 by 2, it will be 1 0 0 1, that is the diagonal, will have one value, and 0 is of course a null matrix, 0 0 0 0. So we have to calculate the A inverse. Now these are the questions which are following. So we need to find out A inverse, here also A inverse. So there are various questions. So let me do this question properly so that you are comfortable in the next questions. So what we'll do here is, this is A, and we'll multiply A with A, that is A square we are going to find out. So this is A, 2 3 1 2. This is also A into A we are doing 2 3 1 2. So A squared we are interested in. So 2 into 2 is 4, 3 into 1 is 1, 3, so 4 3, 2 3 and 3 2, then 1 2 and 2 1, and then 1 3 and 2 2, multiplied and add. So this is A square. A square will be what? It is going to be 7, this is 12, this is 4, and this is 7. A square. Now we have to put this in this expression or identity. So I am putting A square here, then subtraction with 4 into A. A is this matrix, so we'll multiply this with 4. So 4 to, I'm multiplying it with 4 and then writing 4 to the 8. Let me write it here. So 4 to the 8 here, 4 3s are 12, 4 1s are 4, and 4 2s are 8. So this is minus 4A. What is the identity matrix? This is simply 1 0 0 1. This is the identity matrix. Okay. So this is equal to 0. So now you can very well see, if you take the corresponding value, 7 minus 8 plus 1 is 0. 12 minus 12 plus 0 is 0. 12 minus 12 plus 0 is 0. Then we have 4 minus 4 plus 0. This is 0. 7 minus 8 plus 1 is again 0. So this is a null matrix which we have to prove. We have to verify. We already verified it. Next step is to compute the A inverse. Now this is a very important step because this is going to come on and off when we go forward. So A square minus 4A plus I. Right? Please remember, always the I term has to be taken in the right hand side or on the other side. Then we multiply the whole equation, left hand side, right hand side, by A inverse. What do you get here? So A inverse can be multiplied in before and after, so it's up to you. The concept remains the same. So A inverse I am multiplying, it can be before A square, it can be after A. But we know because of the properties, thus if you multiply A inverse or anything with I, it will be the same one. So A inverse I is A inverse. So A inverse cancelled here, minus 4I. Here also it gets cancelled, A minus 4I. So A minus 4I is minus A inverse. And negative you can always take here, and you can write A inverse as 4I minus A. Okay. So 4I minus A, when you multiply 4 with the identity matrix, you get 4 0 0 4. So I'm writing it here, 4 0 0 4. And then we have minus, and then what we have to write A 2 3 1 2. So we get 4 minus 2 is 2, 0 minus 3 is minus 3, 0 minus 1 is negative 1, 4 minus 2 is 2. So exactly same thing has come. Okay. Now this is also a same question like this. So A square, that is you have to multiply the matrix twice. Means the same matrix had to be multiplied with same matrix, then 4A minus 42I. And as I said, 42I has to be taken on the right hand side. But before that, you have to satisfy the equation, verify the equation. So put this a square, a, that is 4a, and minus 42i here, and then that has to be equal to 0. Now after verification, a square plus 4a minus 42i equals 0. And as I said, the identity element content or the term has to be taken on one side. So just multiply this all with a inverse. So a inverse, one of these will cancel a dot a inverse. So this gets, this is I into a will be a only. Then this also goes 4 into I, a into a inverse is I, and equals 42 I into a inverse. You multiply anything with I, the same element will come. So a plus 4i, I hope you will be able to do. A is already there, and just divide it by 42, or you can say multiply it by 1 by 42, and this is going to be a final solution. Same thing here, exactly same thing, and first you have to satisfy, then find the A inverse. Here also the same thing, but only one aspect here is x and y we have to find out before we go ahead and find out the A inverse. The equation is, or the equality is, a square minus x into a plus y into I equals 0. So first we have to find out x and y, put it in this equation, then we'll go for the next step, which is finding out of the A inverse. So I'll show you to you here only. A square minus x into a. So multiply this with x, 4x, 3x, 2x, 5x. Multiply this with I, means I with y. So wherever 1 will come, y will come. And then you equate it with 0. So 22 minus 4x plus y. 18 minus 2x plus 0. 27 minus 3x plus 0. 31 minus 5x plus y. When it equate to 0, 27 minus 3x equals 0. 3 7s are 3 9s are 27. And 18 minus 2x equals 0. Let me show you here only. 18 minus 2x equals 0. And that will give you 18 equals 2x, x is equal to 9. I'm just trying to suggest that we have the x value. Put it in any of the equation. So 31 minus 5x minus y equals 0. X is 9, 5 9s are 45. So y will be equal to 45 minus 31. And this is not 31 minus 45. It will be 45 minus 31. So when you get y equals 45 minus 31, it is going to be 14. And when you get 14, x and y is already computed now. Now you have to replace this x and y in the original equation, which is a square minus 9a plus 14i. So the final equation will be something like this. A square minus 9a plus 14i equals 0. Now multiply it with a inverse. And always take the identity element term on the right hand side or the other side of the it can be left hand, right hand, whichever you want. So a minus 9i equals minus 14 a inverse. So a minus 9i compute it and just divide it, or you can say multiply it by minus 1 by 14. This is your final answer. Same thing you are going to do here. There is no difference because here you have to find out lambda. Previously, in the previous question, I told you how to find out x and y. Here also, when you actually equate it, a square you need to find out. I hope you'll be able to do it. Lambda into a, so 3 lambda minus 2 lambda, 4 lambda minus 2 lambda, and minus 2 into I, 2 into 1 0 0 1. So when you equate it, lambda will be 1, and then you can find out the A inverse. So this is also exactly like this. The only difference is it is not a square minus 3a minus 7. It is actually saying that this is satisfying the equation. So you'll put a in place of x. Similarly here, in place of x, you are going to replace 6 5 7 6 a here. And the same criteria, same logic which I showed you, you have to do it here. A is actually satisfying here. So a square minus 12a plus 1, you will not write 1 then. You have to write the identity element here. It will be I2. So now then you have to do the same thing which I told you, and then you can find out the A inverse. So this is a kind of a different question. So this is a 3 by 3 matrix. So we'll try to find out and how to solve this. The step will remain same. There will be a, it's not a raised minus 3, it is a raised 3. This is a raised 3. And first we have to equate, that is, first you have to show that this equation is equal to actually null matrix. So a cube, you have to multiply a, that is a 3 times. So I hope you will be able to do, because multiplying a 3 times will take a lot of time. So I'm just telling you that a into a, and then multiply a into a with a. So finally this will come. I hope you will be able to do it, okay? This is just matrix multiplication. So a into a into a. So once you do it, you will get a cube. It is 871 minus 23, 27 minus 69, and 32, negative 13, and 58. So this is your a cube. Once you do it, you multiply, you then subtract it with 6 into a square. A square is already there. So why not to multiply this 6 with internal element and then compute it. I'm just writing it, but I hope you will be able to multiply this and then add. Then we have 5 into a. Just multiply 5 with all of this. So 5, 5, 5. Then we have 5. 5 to the 10. 5 is the 15 minus 15. Then 5 to the 10 minus 5, and 5 is the 15. And then we have 11 I3. I3 is what? This is 1 0 0 0 1 0 0 0 1. This is your 11 into something, the I. So wherever 1 is there, you just replace it with 11. Now you have a simple addition of or subtraction of matrix, combination of matrix, addition, subtraction has to be done. So multiply this inside with 6, and then take the corresponding element and add and subtract. So I'll just show you how to multiply this 6. 6 to the 24, 6, this 6, 6, 7, 6 is 18, 6, 8 is 48, 6 into 14, that is going to be 6 for 24, 4 to carry hand, 6, 1, 6, 2, 8, 84. This is 42, this is 18, again 84. Okay. Once this is done, same thing, just see here, 8 minus 24 plus 5 plus 11. Okay. Same thing you have to do. And you have to do it for all the 9 elements here, correspondingly one by one. Okay. So once this is being done, you get that as to be 0. You will get a null matrix. That is just the, you have just showed that it is 0. But in order to find out A inverse, you'll use this equation. That is, you have A cube. Same thing, right? Minus 6a square plus 5a plus 11 into I3. And this is equal to null matrix 0. Now multiply this with A inverse, every element. So A inverse, one of the A will cancel out. A square minus 6, one of the A will go, 6a plus 5a into A inverse will be 5i plus 11 into I3. So this 11 into I3 we have to take on the other side. And when you multiply this I with A inverse will come. So this 0 will also be multiplied by A inverse, and that will be 0 only. Now as I told you, always the item has to be taken on the right hand side. So 11 A inverse, you can get this as minus A square plus 6a minus 5i. Now A square is with you because you have already calculated A cube. For that you must have calculated A square. A is already there. I is identity element. Put it here, do the simple addition and subtraction of the matrix, and finally you can divide it by 11 because 11 is already there on the left hand side. So final result is what I am suggesting you here. This is your final result, right? This is A inverse. Okay, this question is also similar to what we have done just now. So just have a look at the answer, and as I said, you have to multiply A with A with A. You have to multiply A 3 times. Then you have to find. You can also do the determinant, because you need to know whether A inverse exists or not. That will be an added advantage for you to ensure that the examiner knows you know everything. So once this is A cube is done, what you will do? Multiply this equation with A inverse. So you already have this idea now. Once you multiply this A inverse, this I3 term has to be taken on the other side, and that will essentially give you A inverse. So A is in A square minus A minus 3I minus A inverse equals 0. So A inverse you can take on the other side. You just have to perform A square minus A minus 3I. A square already you have computed. A already is given. I identity you already know. Simple matrix addition subtraction you have to do. So this is also almost similar to what we have been doing up till now. So this is kind of practice, There are so many questions. Just need to practice the same question with different numbers again and again. Now this question, this is A inverse equals A transpose. A cube also will come. A cube also will come. So A inverse we have to find out. And then we have to find out the A transpose. So if this is A, how are you going to find out the transpose? So A transpose will not be like this, that you transpose the matrix and then you keep that 1 by 9. No. When you have 1 by 9 here, well, it won't affect, but still you have to convert the row and column, that is rows to column, and then you have to multiply 1 by 9 inside. But since this is just a transpose, so I'm keeping 1 by 9 outside, and then row and column we are exchanging. So A inverse is adjoint of A divided by the determinant of A. In order to find out the determinant, just see scalar. In order to find out the determinant, you cannot find out the determinant of minus 8, 1, 4, that is the inside matrix, and multiply it by 1 by 9. No, that is not the case. In order to find out the determinant of this, you have to multiply 1 by 9 inside. That is determinant of A. You cannot have 1 by 9 and then you compute the determinant of inside and then multiply. No. You have to multiply 1 by 9 with each and every element inside first. Then we'll take it outside. How? I'll just show you. If you multiply this 1 by 9 inside, you'll get minus 8 by 9. And then 1 by 9. And then 4 by 9, 4 by 9, 4 by 9, 7 by 9, 1 by 9, minus 8 by 9, 4 by 9. So just multiply 1 by 9 inside. This is a scalar multiplication. We know that in order to find out the determinant of A, we need to multiply this all inside. Now, we can take 1 by 9 from either 3 rows or either 3 columns. That's up to you. I hope you are understanding the concept. 1 by 9 you have to take. So, 1 by 9 will come from first row, 1 by 9 will come from second row, 1 by 9 will come from the third row, and this is almost similar to 1 by 9 coming from the 3 columns also. Essentially, the final output will be 1 by 9 into 1 by 9 into 1 by 9. That has to come out. Now whatever is inside, now you can take the determinant of it. So that is the catch here. That is the thing we need to understand. Now let us find out the determinant. So when we multiply this, you can open it using any of the row, any of the column, because doing it, making it 0 will take time. So minus 8, 4 minus 8, 7, 4. Here you have minus 1 and 4, 1, 7, 4 plus 4. Then 4, 4, 1 minus 8, 4, 1, 1 minus 8. Now this has to be multiplied by 1 by 9 into 9 into 9. So 4 4 is 16 plus 76 minus 16 minus 7 plus 4 minus 32 minus 4. So rather than going into the detail of simple mathematics, I'm just going to tell you the answer. Once you compute it, you will know that this answer will come as -1. So the determinant of A, we fix it and we finalize it to be -1. Once you have done it, now we have to find out the adjoint A. Determinant of A we have already found out. Now, see, first you have to multiply inside. Adjoint A, first you have to multiply this inside, and then, because you cannot have things taken out and then find out the adjoint of inside one. No. As I said in the first transpose case also, another cases also, you have to multiply this 1 by 9 inside, that is the scalar multiplication, and then we will compute the cofactors. Cofactor can be only computed like this. So I am taking 1 by 9, making it a proper matrix. Now we are ready for the cofactor. So I will tell you certain cofactor. Let us take two of the cofactors. Minus 8 by 9. What is the cofactor? Cofactor will be, see, minus 1 to the power, the C11, so 1 plus 1 will come here. We have inside 4 by 9. This is 7 by 9. This is negative 8 by 9. And this is 4 by 9. So what do you get? Now you can take 1 by 9 common from either two rows or either two columns. So 1 by 9 into 9 will come. Maybe from two rows or two columns. What is inside? 4, 7 minus 8, 4. So 4 4s are 16, minus become plus 56. This is 56 plus 16 is 72. 72, 9, 8, 8 9s are 72. You get 8 by 9. So I hope you got the idea of how this C11 has come. I'll give another option also, another description of C33. So C33 minus 1 to the power 3 plus 3, that is going to come as 1 only. And what will be there? As I said, 9 9 we have taken from two rows or two columns. So minus 8 1 and 4 4 will come. It is going to be minus 8 4 so 36 minus 36. Then minus 34, 32 minus 4, that is minus 36. So minus 36 by 9 into 9, so 9 4 36 minus 4 by 9 will come. So I have given you two of the cofactors. I hope you will be able to find out all the cofactors. So once you find out the cofactor, then you have to transpose it. You have to transpose it and then you have to multiply this, divide it by minus 1. Because why I said divide or multiply? Because together, because minus 1, if you multiply or divide, it remains the same. The result will remain the same. So this is how, once you transpose, this is going to be A inverse will be equal to A transpose. So I told you about A inverse equals A cube also. A inverse, you know how to find out A cube, that is you have to multiply A 3 times. So this is A square is this one, A into A. This result will come, then A cube, you multiply A square with A. So you get A cube here, okay. Now, once you find out the A cube, how it is going to be equal to A inverse? A cube we have already found out. A inverse is what? Adjoint A by determinant of A. This is one way you can do it. But rather than doing it, we have a simple solution here. What is the solution? A cube is A inverse, you have to prove. But once you do A cube, you get certain value. And once you multiply A cube with A, I am just telling you to multiply A cube with what? A. So when you multiply, you have to do it by yourself. That thought should come into your mind. A cube into A. So once you do it properly, if you see here, that is going to come as identity matrix. A cube, if you multiply by A, you will get the identity matrix. So once you multiply something with A and that comes to identity matrix, that thing is going to be A inverse. I hope you got that idea. See, if you multiply here, do it by multiplying with A inverse. So A cube is A inverse here. Okay. So we tried A cube we already had. But in order to make it as A inverse, why not to multiply with A and show it to be an identity element? Because B multiplied with something, that is X is I. So X has to be B inverse. Because B into B inverse is I. So when you multiply something with A and it comes to be an identity element, A cube is what? A inverse. Okay. So A inverse multiplied by A is an identity element. This is the concept. Okay, this will do in the next discussion. Till then, thank you so much. Take care of yourself.